Okay, backing up very slightly, number 8 for the typicality. There's a company that has shipping containers. And oops, I forgot to grab the previous problem that had the numbers. I have to do 7 to answer number 8, which someone asked about. So let's do that. So the mean is the total divided by how many? So if I add these all up, assuming I don't hit anything wrong in my calculator, I got 217. And I divide by 7, and I got, oops, 31 tons. Then the median, I have to take the sorted list. It looks like it's already sorted, and find the middle. So there's 3 on that side, and there's 3 on that side. So the one in the middle is the 18. Okay, questions about 7 before we move on to 8? So if a typical container weighs either 31 or 18, and there's 7 containers, then if I multiply by 7, I should figure out how much we get total, right? So let's try it both ways. So clerk number 1, he is going to do the mean times 7. And that's going to get us back to 217 tons. And that's great. That's what the total actually is. That clerk got a good answer. Clerk number 2, he read the different report. He only knows the median. So he says, well, that's, if the typical one weighs 18, then 18 times 7 should give me a ballpark of how much the whole shipment is, right? So he's getting 126 tons. So that's bad news. If he orders a truck based on that, it's not going to have enough space. So the moral of the story is if you're trying to work to a total from a typical measurement, pick the median. Don't use the mean for that purpose. We were also asked, we're not quite done, how much error does he have? So it looks like 91 tons if I'm doing my mental math right. What if the problem was different and said, what percent error does the other clerk have? How would we change 91 tons into a percentage of error? That subtraction you mentioned is how we got the 91. Remember that our percent change is change divided by original. I think we've done that a few times. So we'll take that 91, that's our change, divide it by the 217, that was our total, and get about 0.42. And I'm rounding, so I should use squiggly equals. So he's off by 42%. Right into percent. Okay, thank you for checking in chat. I don't think the answer is when you go to enter your work, ask for the percent. I think the 91 tons is what they ask for. But if it did ask you the percent, now you know how to do it. Any other homework questions or old topic questions? Okay, let me pause the new material. So we've done good homework questions. Now we'll talk about some new stuff. With personal finance decisions, we started by talking about typicality, and then bell curves, and then mortgages. And we've had lectures about all of that stuff. We can always do more if you need some review. There were some things that were just read at home, so I'm not simply reciting things to Zoom that you could read by yourself, especially in the bank safety section and the bell curves thing. So read through this if you haven't, but we're going to move on and talk about saving for retirement. We've already done a lot with percent sentences. So there's a review section here, just in case you need it, but we've talked about translation and proportion method for percent sentences a couple of times already. So we're going to jump right to interest. This is a pretty long section. So interest, simple interest, we'll get through that today probably. There's a activity about 6 years of an apartment rent increase and how the rent changes year by year. And that transitions us from simple interest to compound interest. Compound interest is kind of complicated, so we'll talk about that and it will take a while. And then there's another formula called the sum of annuity due, which is used for saving for retirement. We'll talk about how much to save for retirement and some examples of retirement saving procedures that may or may not actually get you enough to retire comfortably. At the end, of course, there's exercises and random exercises. First, we're talking about interest. Interest is a fee that someone who is lending money charges the borrower. For your savings account or a government bond, you are loaning money to the bank or the government. Since you are doing the loaning of money, you get the interest, right? Your savings account pays you interest. A government bond pays you interest. Other times, you are the borrower. When you have a debt, like a bank debt or a credit card debt, then they are the loaning money to you, so they get the interest. The initial amount of a loan is called the principal. And we already saw this term principal used with mortgage loans. So the simplest loan, the simplest percent sentence setup would be if there was a loan for 1 year with one payment. Let's do that on the whiteboard. A loan with least math would borrow money for a year, and at the end of the year, the borrower pays back the loan and the interest. So a $100 loan lasts a year. It has 12% annual interest rate, meaning only once per year do we worry about how much interest is due. So we need to ask, what is 12% of 100? And if we translate this, what becomes y, is becomes equals, 12% with riplop becomes 0.12, of becomes multiply. I guess we might as well put our dollar signs in, and we get $12. How much do we pay back at the end of the year? Well, first we have to pay back the loan. We don't get to keep that money. And then also we have to pay the interest, and we get 112. So far, so good.
Yeah.
Okay, moving on. Notice that when we did that, the 100 times 0.12 is 12 and added it back in, then the principal disappeared, right? The 100 went away. We had to put it back. So what if there was a way to avoid that, make it easier for us? We know that multiplying a number by 1 doesn't change the number. So let's take advantage of that. We're going to do the exact same problem, but using what we call the 1 plus trick. So we're not going to say what is 12% of 100 like last time. We're going to say what is 112%. We're putting a 1 in front of that 0.12. And that comes from the fact that we have 100% plus 12%. The 100% is the principal. We have to pay all of that back. That was here. The 12% is the interest. We have to pay that also. That was here. And rather than add them up at the end where we have actual numbers, we're just going to put a 1 in front of the decimal, because that's so easy to just put a 1 in front of a decimal point. And that means when I multiply, I get my answer all in one step. So let's do another example just of the 1 plus trick. We're not going to worry about interest right now. So let's have a city population and just call out or put in chat, how big should our city be?
Let's do 100,000.
100,000. Okay. Whoops, I put dollars. I'm still in money mood. Okay, 100,000 people. And it grows say 8%. So we could do this with 2 steps. So 0.08 times the 100. Oops, I'm putting dollar signs all over the place. 0.08 times 100,000. That's going to be 8,000 more people.
There's a hummingbird.
Then we take the 100,000 that we had before, because they haven't gone away, and add the 8,000 new people and get 108,000 total. Or we could use the 1 plus trick. And say that we're going to take that 100,000 and we're going to multiply not by 0.08, but by 1.08. Put a 1 in front to represent the 100% that sticks around. And that will give us the 108,000 all in one step. Okay, questions on this slide? Any confusions about the 1 plus trick?
It's good for me.
Good for you. Okay, now let's actually move on with the interest. So, we did the 1 plus trick. Okay. So far, our story about interest has been the simplest case. A certain amount was loaned, there was an annual fee, and at the end of 1 year, we just found how much that fee was. What about if it lasts several years? And for some people, this is going to seem really unrealistic because they haven't seen simple interest in real life. So imagine, if it helps you, that we're going back in time. This is like a Doctor Who episode, and we're looking at banking before calculators. There's a $100 loan. It lasts 5 years, and every year we pay 12% of that principal. What's the total amount paid? So we ask, what is 12% of 100? And again, just like we did a couple of slides ago, that's $12. Then, because it lasts 5 years, at the end of the first year, that's 12. At the end of the second year, that's another 12, and so on. And 12 times 5 is going to be 60. So at the end of all 5 years, the person will have to pay first the 100 for the principal, also the 60 for the 5 years interest, and get And if this seems wrong to you, it's because you're used to how modern math with calculators works, where the banks will say each month you not only will owe what you did before and pay interest on that, but you'll also have to pay interest on the new amount. If you don't pay off your credit card fully, then your interest goes up and up because you pay interest on the debt that increases. But we're not there yet. That's later. For now, all 5 of our interest payments were only based on the original principal, on the original loan size. We just have exactly the same copies, 12 and 12 and 12 and 12 and 12 is 60. So you may not have seen that in real life, but you could imagine going back in time before there were lots of calculators where you might be a bank that offers this kind of loan. You'll just pay the same amount each payment. It's simple. We don't have to do complicated math. There we go. You could do exactly the same thing, whoops, with part of a year. Maybe you didn't need your loan for a whole year. Let's just have a 6-month duration. So as before, it was $12 for 1 year's interest. But my loan this time is only 6 months. So the bank has 2 business options. One is to say, tough luck, you paid your loan back early, but we had agreed that it would be $12 as a fee for the loan for the year. And if you pay your loan back early, you still have to pay all $12. There's nothing wrong with saying that if that's how the contract was written. But if a bank decided to do that, then they would be unpopular. Another bank would say, oh, good for you. You pay your loan back after half the time, so we'll only charge you half the interest. So we're going to do divided by 2 because it's only half a year. So this person only has to pay back $6 interest for 6 months. At the end of 6 months, they would pay $106. And you can see why that would win out socially. The banks that say, nah, you have to pay the $12 wouldn't be able to keep being strict in that way. They have to compete with the banks that allow you to have a proportional interest rate. Sometimes we have fractions. Whoops, why did I open Google? That's not what I wanted. There. So now we have our $2,000 loan, 20% annual interest. So that's going to say at the end of the year, what is 20% of 2,000? And we get $400. So that's per year interest. But our loan wasn't a year, it was 200 days. So what do I do? Any ideas? going to take that $400 of annual interest, and I say, what fraction of a year do we have? We have 200 divided by 365. Does it make sense because there's 365 days in a year? That's my fraction. And find whatever that is. Your calculator might have a key that does fractions that would look like this, A, B over C. And I can talk about how to do fraction math on a calculator another time. But for now, let's just remember that division bars and fraction bars are like division. So if I want to write that more calculator friendly, I would actually write it as 200 divided by 365. That's the same as the fraction I just had on the board a moment ago, but now it looks like something I can type into my calculator better. So let's do that. 400 times 200 divided by 365 gives me $219.18. Double check that your calculator gets the same answer. Any questions so far? So this was too much writing. We are lazy. We don't want to do all this work. If you noticed, what we did before was find the percent of means times and the principal. We multiplied those two together. And then we multiplied it by how many years there were. And if there was a whole number of years, that worked. If there was a 0.5, that would work. If there was a complicated fraction of a year, that would work. We're just multiplying it by how much of a year or how many years. So rather than reinvent the process each time, people wrote a formula about this, the simple interest formula. So simple interest is principal times the annual interest rate times the number of years. Let's put that nice and big on our board. Some people like having the letters instead of the words. And if that works for you, if you're used to that, you can, but be cautious with it, because if all you have is P times R times T, remember that the rate is an annual interest rate. If someone gives you a rate that's not annual, maybe it's monthly or something, you have to change it. And the T has to be in years. If they gave you 0.5 of a year, you'd multiply by 0.5. If they gave you 200 over 365, then you'd multiply by that fraction. So the time has to be in years. It can't be in months or days. But as long as you remember that, you can remember this however you want. Principal times annual interest rate times the time in years. So let's do another one and see how easy this is. So we have the principal is 3,500. The interest rate is 4.5%. So if I flip-flop that, I get 0.045. And the time is 9 months. So what will I put in for the time?
Wouldn't it be 3/4?
It would. So maybe you are smart like Mattia and can just look at 9 months and say, ah, that's 3/4 of a year. If your brain was tired, you just woke up, haven't had coffee yet, you're on a math test and your brain just froze because you're taking a test, whatever, you can always say that you're going to take the 9 months and then divide it by 12 because we're dealing in months. If we're dealing in days, you divide by 365. If you're dealing in months, you divide it by 12. It's just saying that out of a year, this is 9 months out of all 12 months. But instead of writing it as a fraction, we're writing it as something friendly for the calculator. But yes, if you could see it's 3/4, you're welcome to just put 0.75 in. Okay, so we plugged things in the formula and our work is done. Now it's the calculator's job, right? 3,500 times 0.045 times 9 divided by 12, and I get $118.13. So that's much better than all this long-winded garbage we've been doing. We did a few problems to see the pattern that we were multiplying the loan amount by the interest rate for 1 year, saying every year that's what we owe. So how many years went by that we copy that? Once we had the pattern, we can turn it into a formula, and there we go. I think we have more. So in this case, the principal is 100. The annual interest rate is 3%, so 0.03. And the number of years is 18 months. Maybe you were awake and smart and look at that and say that's a year and a half, so 1.5. If your brain isn't that agile right now, then you can just say we're dealing in months, so we're going to divide by 12 afterwards. And ta-da, we plugged it in. Now the calculator does its job. 100 times 0.03 times 18 divided by 12, and we get $45. No, $4.5. I was going to say that's way too much. Okay, $4.50. So that's the simple interest formula. There was a nice picture here that, remember, this is old-fashioned. We don't want to deal with complicated math. The bank says that at the very beginning of the loan, we're going to give you an interest rate that's based on the principal and only the principal. And at the end of 1 year, you pay us that much. At the end of a second year, you pay us that much again. At the end of a third year, you pay us that much again. So how much money you owe us goes up in a straight line. If I could actually draw a straight line. Because every year you just have that same payment. And at that point, we're kind of done with simple interest. As a footnote, appreciation and depreciation are when things go up or down in value. Your house, your car, a famous painting. And we can treat appreciation just like simple interest. It's not a fee being charged by a lender, but it's something going up by this %. So we can treat it exactly the same way. Depreciation we have some subtraction going on. So our 1 plus trick isn't going to work anymore. You'll have to kind of go back to the beginning of the lecture and do things in 2 steps. As a heads up for what's going to happen, we're going to say, here is a apartment that starts at a $500 rent, and every year it goes up by 5%. And we'll see that the first year, it's 25 bucks of increase. But the second year, the increase will be more than that, because we'll be basing the 5% not on the 500, but on the 525 that we're starting out with for year 2. And because the percent increase changes and gets slightly bigger with each year, it's a little more complicated. We'll make a pattern out of it and get a formula, and that will change to teach us about compound interest. So here's the other picture that goes with compound interest. Let me shrink that a little bit so we can share the page. Okay, good enough. So this one was simple interest on the left. So each payment was the same. In contrast, for compound interest, it will work like the rent increase, how your credit card works. So at the end of the first month, usually it's monthly for compound interest, then we're going to say you owe this much based on the principal. And assuming you don't pay anything off, let's pretend that you are a completely irresponsible person and don't pay any of your credit card. Then at the end of the second month, you will again have that same amount of interest based on your principal, but you will also have another bit of interest based on your first payment that you never made because you were late. And then your third month, you will still have some of your payment based on the principal, just like before, and some of your payment based on the principal, the payment you didn't pay off the first month. And again, how much you didn't pay the second month. And then again, how much extra you didn't pay the second month that was more than what was due the first month, and so on. So now when we try and draw our line, it's not a straight line. It's going to get steeper and steeper and steeper and go up, which is why compound interest is so financially terrible. So payments increase. And if you get that in your brain, you'll be ready for next week. Okay, I'm gonna stop the recording. We're a minute over.